Okay, this is part 2 of elements and atoms. In this video we're going to cover isotopes. Okay, so an isotope is an element with different number of neutrons. Okay, so in the first video we talked about the subatomic particles, the protons, the neutrons, and the electrons. Let me show you the picture of the last video. Okay, so in the atomic nucleus we have the protons, neutrons, and on the outside we have the electrons. Okay, so an isotope means that atoms can have different number of neutrons. Okay, the number of protons is the same for every atom, so the number of protons doesn't change, and the number of electrons doesn't change. Okay, so the atomic number, which is the number of protons, stays the same, but the neutrons in an atom can actually be different. And that's what an isotope is. An isotope is an element with a different number of neutrons. Okay, we spoke about, again, atomic number is the total number of protons in the nucleus, and atomic number is represented by the letter Z. Mass number is represented by the letter A, and mass number is the total number of protons plus the total number of neutrons. Mass number is not the same thing as atomic mass. Atomic mass is the average mass based on isotope abundances. And what this is that in nature you have different types of the same atom. So for instance, you can have different types of the same carbon atom, and the carbon atom can have different types of neutrons. For example, a carbon atom can have 6 neutrons, or 7 neutrons, or 8 neutrons in nature. But what happens is that these atoms occur at different proportions in nature. For example, the carbon atom that has 6 neutrons is actually the most abundant carbon atom in nature. It makes about 98% of carbon atoms. And this carbon atom over here has 8 neutrons, and this one is the least abundant in nature, because this one undergoes a process called radioactive decay. And what this means is that this atom can actually turn into another atom, because this one is extremely rare and radioactive. So atomic mass, you calculate it by finding out the average mass of all of these isotopes in nature based on their abundances. So if you look at the periodic table, the atomic mass of a carbon atom is 12.011. Okay, so this only tells you that if you find all if you find the weight of the carbon atom with 6 neutrons, and you find the weight of the carbon atom with 7 neutrons and 8 neutrons, and you measure them based on their proportions of abundancy in nature, then you will get this calculation. So this atomic mass is simply an abundancy calculation in nature. Okay, whereas mass number is the protons plus the neutrons. Okay, so again, I mentioned that there's 3 types of carbon atoms in nature. Okay, this carbon atom has 6 protons and 6 neutrons. The protons always stay the same. The protons is what identifies the atom as being that type. For instance, every type of carbon atom has 6 protons. So if I were to say you have an unknown atom, but that unknown atom has 6 protons, then you immediately know that's carbon, because the protons is the same for that specific atom. Okay, when you add the protons and the neutrons, you get the mass number. The mass number is represented by the letter A. So the mass number of this carbon atom is 12, the mass number of this carbon atom is 13, and the mass number of this carbon atom is 14. Okay, and these are isotopes. Isotopes, remember, have different neutrons. So here we have three different types of carbon isotopes that exist in nature. Okay, so the isotope that has a mass number of 12 is called carbon 12, and it's written first with the name of the element or the name of the atom. Then you write a dash, and then you write the number of the mass number. Okay, so this is carbon 12. Then you have carbon 13 and carbon 14. Another way to write isotopes is by putting the symbol of the atom on the right side, and the mass number, you write it at the top as a superscript, and you write the number of protons in the bottom as a subscript. So this is called carbon 12, this is called carbon 13, and this is called carbon 14. Okay, and here I wrote the formula so that you know how to write the isotopes. X represents the symbol of the atom that you're talking about. So in this case, we're talking about carbon, so that's why I wrote a C there. A is the mass number. The mass number of carbon 12 is 12, and the Z stands for the atomic number. Remember, atomic number is the number of protons. So here where it says Z, I wrote 6 because 6 is the total number of protons for carbon.